Hello, welcome to Technoveda Solutions.
In this video, we will discuss about virtual functions. How are they defined? How are they used? How are they invoked? And why do we use a virtual functions? All we'll discuss in detail. So let's begin. Now, the virtual functions are another type of polymorphism. Now, already we have discussed about the compile time polymorphism, that is function overloading and operator overloading, and also we have discussed about function overriding. If you have not seen those videos, you can check in the playlist, or I will give you the link in the description box. You can watch them as well. So today we will be discussing about virtual functions. Now let's see what are the virtual functions and their properties. Virtual functions are defined in the base class and again redefined or overridden in the derived class. Now we know that when the function is defined in the base class and if the same function is again redefined in the derived class, then that concept we call as overriding concept. Now here when we have a virtual functions in the base class, they are overridden in the derived class. Now which function to be called, whether the function from the base class to be called or the function from the derived class to be called, that is resolved during runtime or execution time. So virtual functions ensure that the correct function is called for an object, regardless of the type of reference used for a function call. So virtual functions ensure that whether the base class function should be called or a derived class function should be called, it will take appropriate decision and it will be invoked. That is why we use a virtual functions. Otherwise, in overridden, what happens? Always the overridden function will be called, not the base class function. But when we say virtual function, when we have a pointer being used to invoke them, during runtime, it will decide which function is appropriate to be executed, and accordingly, the function is invoked. So, they are mainly used to achieve runtime polymorphism. So, that is which function to be called, that will be decided during runtime. The functions are declared with the virtual keyword in the base class. So virtual is a keyword, so which will be used to define the virtual functions. When we go to code, I will show you how to define a virtual function using virtual keyword. The resolving of a function call is done during runtime. As we discussed, it's a runtime polymorphism. So resolution of the function call is also done during runtime. Now, there are certain rules to be followed in the virtual functions. First thing is virtual functions cannot be static. We cannot have a static virtual functions. That's the first rule. A virtual functions can be a friend function of another class. What is a friend function? We'll see later. But right now we'll just understand that a virtual functions also can be a friend to another class. And virtual functions should be accessed using pointer or reference of a base class type to achieve runtime polymorphism. This is important. Not we are not accessing a virtual function using a object, rather we'll be using a pointers to access the virtual functions. Only then we will achieve the runtime polymorphism and we will get the advantage of virtual functions. Then the prototype of virtual function should be same in base as well as derived class, because when we expect it to be overridden in the derived class, the prototype should be same in base and derived class. Virtual functions are always defined in base class and overridden in the derived class. However, it is not necessary or not mandatory for derived class to override all the virtual functions all the time. If the virtual function is not overridden in any of the derived class, then automatically base class version of the function is used for the operation if it is not overridden. If there are two functions, one function in the base class and overridden in the derived class, then during runtime, depending on what pointer is calling the function, depending on that, an appropriate function is invoked. If the function is not overridden in the derived class, then automatically base class function is used, even though it is defined as virtual. A class may have a virtual destructor, but we cannot have a virtual constructor. Now we know that constructors are also a special type of functions which have same name as that of a class. Already we have discussed about the constructor as well. You can watch that video also. I will give you the link in the description box. So we cannot have a virtual constructor, but we may have a virtual destructors. Okay. Now, in this image, we will see how exactly a virtual function is implemented. So here we will be using a pointer. Again, if you don't know what is a pointer, then go back to the pointer video, watch that video, and then you can come back here to understand the operation in the better way. So now here we have a class, that is a base class, that is class base1. Then in a private scope, we are defining one value, that's a variable, and then an pointer is defined here. Now this pointer I have marked in a different color because we are not defining this pointer. That means user is not defining this pointer, or a programmer is not defining this pointer. This pointer is defined by the compiler. So you can observe that the pointer is starting with a single underscore, and we know that if it is a user defined pointers or any user defined variable we have, we will always start with the alphabet, not with a special character. Now here the pointer is starting with the underscore, means this pointer is compiler defined variable. So this is a compiler defined pointer. And one more important thing is, this pointer is a static pointer. It will defined as a static pointer. That means when we have a static pointer, this will be shared by all the objects of the class. We don't have a separate pointer for each object. We know that when we have a normal variables, each variable are exclusive for each object. If we have 10 objects created from the class, we have 10 different memory locations allocated for each object and their respective variables. But this pointer is a shared one, and all the objects will share the same pointer. That is, this is a static pointer, so which is called as a virtual pointer. Now this virtual pointer is pointing to a table which is called as virtual table. Here you can see a table which is a virtual table. So this pointer will have an address of this virtual table. This virtual table stores the pointers pointing to a virtual functions. That means this virtual table is an array of function pointers. When we say function pointers, that means they are the pointers pointing to a function, or pointers storing the address of a functions. And remember, in this table we will have a function pointers only for virtual functions. If we have a non-virtual functions declared in the class, the address of those non-virtual functions will not be there in the virtual table. Virtual table contains only the functions which are declared as virtual, and the entry in the table is in the same order in which they are defined in the class. In the same order they will be entered in the virtual table. Then here you can see we have defined two functions. Anyway, this declaration and all we'll see in the code. Here we only understand our virtual table and this virtual pointer very clearly how it works. Then when we derive another class from this base class, that is class derived one from the base class within the public mode, we know that all the public functions which are there in the base class will be derived. So here in the derived class also there is an virtual pointer created, and this is a separate virtual pointer. This virtual pointer is independent of this virtual pointer. There are two separate pointers in different classes. Okay. Now this virtual pointer creates its own virtual table again. The virtual pointer which gets declared in the derived class will point to another virtual table which belongs to derived class. So the virtual table of the base class is separate, virtual table for the derived class is also separate. Now, if the virtual functions which are there in the base class and derived in the derived class, if we have a overriding function for that, then that overridden function address will be stored in the virtual table. And if any virtual function of the base class is not overridden in the derived class, then derived class virtual table will store the address of the base class function. I'll repeat. If the virtual function of the base class is overridden in the derived class, then virtual table will have the address of a function which is overriding the base class, that is function defined in the derived class. And if the virtual function defined in the base class is not overridden in the derived class, then virtual table will have a address of a base class virtual function itself in the virtual table. Now, this is how the virtual table and their entries are created. So how many entries will be there? That depends on how many virtual functions we have declared. All the virtual functions will have one pointer defined chronologically in the virtual table. Then when we go to a main function, here you can see one base object and one base pointer is created. And we are also creating one derived object. So if we call a function using a base class object, okay, then no issues. Will whatever the function we have, that function will be called because there is no ambiguity here. Now if there is a base class pointer having the address of a derived class object, now remember here we have a base class pointer pointing to a derived class object, okay, then when we call a function using a base pointer, okay, when we call a function using a base pointer, then the function will be called which is there in the derived class because it is overriding that. So this function will be invoked. Now if the function 2 is called, which is again called using a base class pointer which is pointing to a derived class object, but still as the function is not defined in the derived class, it will invoke the function from the base class. This virtual function only gets invoked. Okay, so to understand the operation of this, let's go to code and we will analyze the invocations of the different functions. Now we'll see how the code is written for the virtual functions. So here we have include a header file, then namespace definitions. Then we are creating a base class. In the base class, there is one function which is not an virtual. We are just declaring a normal function. And then we have three virtual function 2, 3 and 4. Okay, so all 2, 3, 4 are virtual functions. See here we are not creating any pointer. As I said, that virtual pointer is created by the compiler and virtual table is also generated by the compiler itself. We don't do it. Okay, then we just inherit one class, that is derived class, in the public mode from this base class. Now in derived class, if you observe, here also we have defined three functions, function 1, function 2 and function 4. So function 1, anyway this is not a virtual, but function 2 and function 4 are virtual functions. Okay, whereas virtual function 3 is not overridden in the derived class. Function 1, function 2 and function 4 are overridden, but function 3 is not overridden in the derived class. We don't have a redefinition of function 3. We have a redefinition for function 2 and function 4 which are virtual, and function 1 which is not virtual. Now when we call those functions, let's see how it is working. Now in the main function, what we are doing is we create one base class pointer and one derived class object. Now the base class pointer is assigned to a derived class object. So this is derived class object, and address of that object we are assigning to the base class pointer, and using that pointer we are calling a different functions. Now when we call a function 1, as function 1 is not a virtual function, immediately it gets binded during the compile time. So that is called early binding, because the binding is happening during the compilation itself. During compiling time itself, compiler knows which function is invoked, so it will bind the function to that particular instruction. Whereas when we call 2, 3, 4, 2, 3, 4 functions are declared as a virtual, so they will be binded during execution, that is late binding or runtime polymorphism. Early binding is done during compilation, late binding is done during runtime. So function 2, function 3, function 4, these call will be resolved during runtime. Okay, so now just we will run the code and check what are the functions which are invoked by the compiler, whether it is invoking a derived class function or it is invoking a base class function. So to understand, you can also observe here, when we are overriding in the derived class, the function 4 is having one variable as an argument, whereas in the base class we don't have any arguments as such. Now if we observe, okay, first when we call the function using a pointer, function 1, base 1 is executed, that is base 1 is executed because the pointer which is calling the function is of base class pointer, so base class function is executed. Okay, then when we call a function 2, a derived class function is executed. Why? Because in derived class we are overriding the base class function. Function 2 is overridden in the derived class function, so derived class function is called when we call the function 2. Now when we call the function 3, base class function 3 is called because this base class function 3 is not overridden or not redefined in the derived class, so obviously base class function is called. Then when we call function 4 without an argument, then obviously this function again base class function is called, which is without an argument. Now if I write one more instruction with argument, then we expect derived class function to be called. Just I will define one variable here and I will assign a value 10 to that, and then I will pass that value because this is an integer. So here you can see, even though we had expected the function to call a function from the derived class, but it is giving an error. That is because we are calling using a base class pointer. So always precedence is given to a base class functions. If the same function is overridden, only then derived class functions will be invoked, as we saw in the previous execution. So that's it in this video. I hope you understood how the virtual functions are used and why they are used. If you like the video, please click on like button and share your thoughts in the comment box, and also you can share the questions if you have any. Please like the video, subscribe to the channel and share the video with your friends. Thank you. Have a good day.